Hi, my name is Hassan. I'm the co-founder and CTO at Red. In the next 8 minutes, I'm going to show you how we're solving the most common problems that designers and engineers face by using artificial intelligence. Red is powered by a semantic CAD AI, which thinks and works like an expert mechanical engineer. It has been trained on all the data that an engineer would learn from, including CAD designs, documents like BOMs, spec sheets, vendor catalogs, and other sources of data. And all of that intelligence is available through the RED Intelligent Design Assistant or IDA. It has been estimated that 80% of the work that engineers do is identical or very identical to something that has been done in the company in the past. So if we can help engineers find the right information at the right time, we can save enormous amounts of time and effort during the product development process. The RED IDEA has powerful search capabilities right out of the box. Through a simple natural language query, the AI can search through all the data that's available in the organization to find the right results. For example, I can give it a query and ask what screws are used in the project. And when I click on the search button, the AI determines that I'm trying to make a query and I'm trying to find parts which are screws and they're being used within a project, which is a data object. The AI goes out, searches through the entire data set, and surfaces the right models that I can reuse along with the categorization for what they are. The IDA can search across any kind of data: CAD designs, documents, BOMs, spec sheets, vendor catalogs, drawings, or any other custom field. The IDA supports really powerful search queries. For example, I can ask it to find me all the materials which are used in a particular project. When I click on the search button, the AI understands I'm trying to find materials from a project. I can then increase the complexity and ask for materials from projects but which have to satisfy a certain criteria. For example, I can ask it to search for materials, but the mass density property of that material has to be 8,000, and it can find that information. This can be made more complex by tying in all the data sources that the IDA can work on. For example, I can ask it which supplier has a motor where the mass is more than 100 grams. And the IDA goes out, looks at vendor catalogs, looks at mass, and figures out which is the right product that I should be using. This is how the IDA works in the background. When it is pointed to any data source, it first determines the kind of data it's working on: CAD designs, documents like spec sheets, vendor catalogs, and then analyzes this data set and classifies the parts that it's able to identify, the standard parts like screws, nuts, bolts. As you can see, it's invariant to the naming scheme because it does a graphical lookup to identify these parts. So the names can be in English, Portuguese, Spanish, doesn't really matter. It also determines what are supplier parts, and it's able to intelligently do this by finding references to the parts within vendor catalogs, and it's also able to extrapolate to the name of the vendor as well. It creates a graphical representation showing the relationships between all of these data points and intelligently classifies them into clusters. These clusters are created based on commonly identified patterns, which could be materials, standard parts which are reused, company parts which have similar names, or if it can decipher some rules within this cluster. When new parts do need to be created, the IDA helps engineers make sure their designs are actually manufacturable. It does this by bringing manufacturing knowledge into the design phase and by making the design validation process early, iterative, and continuous. Engineers can release their designs to manufacturing with much more confidence. The IDA automates design for manufacturability checks. It makes sure that design engineers are staying within the lines as they create parts. In this case, let's take a motor. As you can see, it has a front plate, a back plate, a few holes, a spindle. a design engineer can enforce rules. For example, the hole diameter should be half of depth. In a machining process, this is a critical rule to make sure that the bit does not flex or bend, and this is a rule that engineers should keep in mind. Clicking on the Analyze button, you can see the AI is able to determine that the hole features should have an attribute which should be half of the depth. And clicking on check, it's able to identify the 8 holes, and it's correctly able to identify that the depth has to match the diameter by half, and it's able to do that. Now we can take this one step further and make the rules more complex and say only the holes on the back plate should be of a certain diameter. Again, clicking on Analyze, the AI is able to determine that holes on the back plate, which is the part over there that we can see, should only be 2.4 millimeters in diameter. Then the check button enforces that rule, and as you can see, only the 4 holes on the back plate have been identified, and then these are examined and found to be appropriate, and therefore this rule is now passed. Now these rules can be defined by the engineer, or they can be found within a very extensive library of rules available across different features, for example holes, and split across different processes, or they can be searched by the actual process itself. So these rules are available, they can be copied and brought into the automated test. There are other tests that can be carried out. For example, wall thickness should be 2 millimeters. In a molding or in a casting process, this is critical. And clicking on the Analyze button determines, the AI determines what the check should be, and then it actually is able to carry it out. In this video, we've barely begun to scratch the surface of what's possible with the IDA. If you would like to join our early access program, where you get access to the software as it is being developed, as well as the ability to influence the roadmap, please reach out to me and I'm happy to take this discussion forward.